recording or like asking questions or anything like that. So bear with me if I sound very like if I sound very new to this compared to maybe those that you might talk to before.
No problem. Your audio is breaking up a little bit.
Okay, I just started the recording. Could it be maybe because it's
It could
started?
be, yeah. This recording, I think Skype is a new thing for Skype, so they might have some bugs in it.
Yeah, it's very, very new, and I think it's a bit heavy, and my computer's a bit old also.
Yeah, that's probably it.
And
Well, sounds good now.
okay, good. No, I'm Swedish. I was gonna say that I'm Swedish, so of course I might say some things wrong or in a way that you're not used to. So if you don't
No, no
understand
problem.
me, just ask me again.
Yeah, I've talked to lots of different people in different degrees of English, so
Okay,
don't worry.
cool. And no, I was just gonna ask you at first because I know that you are pretty good at modeling. You have been both sort of studying that and doing like practice. You have practiced like doing modeling, I've seen.
Yes, I built. You mean physical models?
Right, right.
Yeah.
Yeah, I think
Yes.
that was very, very good. So I thought I could ask you one thing about that I have thought about actually.
Okay.
Because in the past, in my group that I have on Facebook, 9/11 conspiracy theories are an inside job. There I have asked some people in the past if I could make like a I can't remember the exact scale, but if you understand me, like um, you make like a 4 meter model.
Mm-hmm.
That would be like 1/100th less than the actual towers.
Correct. Yeah, because that's about 13 feet, and the tower's like 1,300 feet.
Okay, yeah. So I was thinking if I would do that, that would be, according to those I have asked, that would be incorrect. So I was wondering if you could like explain to me how it would be incorrect to do
Well,
that.
it depends what you're actually trying to achieve. The problem when you scale things is a thing called the square cube law,
Okay.
where
Right.
the strength of something is proportional to the square of its length, but the weight of something is proportional to the cube of its length.
Okay.
So if you make something twice as tall, it gets 4 times as strong in terms of like the resistance it can do to bending forces and things like that, but it gets 8 times as heavy.
Oh wow.
So if you take a very, very large building like the World Trade Center and you were to scale it down, you have to make things correct proportionally. You have to increase the weight. So you have to use a much denser medium, or you have to decrease the strength. So you have to use a much less strong medium. So you end up having to make a compromise because you can't do something really that's exactly the same because materials change as well when you make them smaller. If you can like imagine the difference between like a small piece of wood and a large piece of wood, the size of the wood grains remain the same, and they themselves don't scale. So if you could make a tiny piece of wood that's like say 1 centimeter long, and you snap it in half, you get these long splinters. But if you take a piece of wood that's 1 meter long and you snap it in half, then the splinters are the same size. So even though you're scaling things and you're building a model that's mathematically in size terms is to scale, it doesn't work in terms of strength and various other things like material properties. So you're always going to have to do a trade-off, and you've got to decide where you're going to trade off things.
Okay. That's very interesting actually. Yeah, I think I recognized that when you said the square cube law. I think that's what people said, but yeah, of course I read about it when they told me, but I still wasn't sure, and I was thinking I could make a blog post that I would post with the same sort of with the same lengths, but just decreased by 100th, but with the caveat that this is not a correct model, but just to give people an idea, because I of course respect that it's not correct, so you couldn't have a correct model if you do this, but it would put like at least the bolts, for example, in perspective, because the bolts they were fairly small, and if you make them 100th less than they were in real life, they become extremely small if you do it like this. In a 4-meter model.
Yeah, they would also essentially be very strong relative to the actual weight of the model. And, they look like they're very, very tiny and very, very weak. But then again, the forces that you're putting on that model would also change in scale. It's kind of a very tricky thing to get right. There's a thread I have on metabunk, which is the use of scale models for investigating 9/11 collapses, and that has some examples that show. I'll send you the link to it. And you see, there's a thumbnail there, and that's an image on the thread, which is of some, I think they're Chinese men, and they're building a scale model of a building, but they're having to load these iron ingots, these small iron bricks, well, quite large iron bricks, onto the floors to simulate the actual building weight. Now they've built the model, I think it's like a 1/10 scale model, which is pretty large. It's unusually large for a scale model. And they were using it to demonstrate that the model would be able to withstand earthquakes. But if they just built the model as is and didn't add this weight, it would very easily be able to withstand the weight of the forces of the earthquake, because it's like it's a bunch of iron things bolted together. So it's incredibly strong for what it is. So they have to add these tens of thousands of pounds, probably, or certainly thousands of pounds. It looks like around, I would guess, like 1,000 pounds per floor by the looks of it. Anyway, they have to add a lot of weight for it actually to simulate the earthquake, and that's the type of thing you would have to do with a 9/11. If you look at the size of this thing, it's like 5 meters tall, the scale model. So it's it's a lot bigger than you would be able to do.
Yeah,
and
but
even then,
it would be a bit similar. A bit similar. I was thinking about a 4-meter model.
Mm-hmm.
So it would be similar in size, but I see that in their construction is a conventional building, so to speak.
Yes. Yeah, that's another thing as well. Like, if you're building the World Trade Center in small scale, if you built it so it was, say, like we say 4 meters or 5 meters, so it's only going to be 12, 13 feet high, which is like twice the height of your average person.
Yep.
It becomes very, if you build it truly to scale, it would have to be very, very fragile. Now, if you think of the type of wind loads that the building will experience, and it has to be able to resist, when you bring it down in size, like just touching the model, if you can imagine, like, if you yourself were scaled up so you were 1,000 feet high, and then you pushed or leaned against, or just tapped with your fist the World Trade Center, that would